Xtreme Everest 2 is building on our previous experiment, and what we're looking at is the staged descent to altitude as the air gets thinner and thinner, trying to understand how humans adapt to the low levels of oxygen that we're experiencing at altitude.
The expedition is a huge research project, and we've set up a number of laboratories to test volunteers as they ascend higher and higher up the mountain to Everest Base Camp where we are here. When we were here initially, the temperatures at night were dropping to almost -30, which is quite difficult to sleep in. And when you get up in the morning, it's still -10 or so. But the investigator team is very cold, as is all the equipment. So it's a hard life.
Not only is it an absolutely brutal environment, you're pushing towards the so-called death zone. It's very, very hard to live there, both from the oxygen availability and the temperature. You're living in tents on broken ground and moving ice. So absolute heroes of this whole endeavour, alongside the volunteers who are being tested, are the researchers who live there for 3 months.
This place is nuts.
So where we are now, 5,300 metres above sea level, and there's approximately 50% of the oxygen in the atmosphere that you're breathing than we will find at sea level.
We all work in places where patients are short of oxygen. For diseases of the lungs or heart or other parts of the body mean there's less oxygen available for the organs. And some people cope with that and some people don't.
If we look at a group of, let's say, 100 people admitted with a pneumonia, you treat them in exactly the same way and about 25% shake it off straight away within a week or so. There's about 50% that we need to bring into hospital and it takes them a month or so to get better. Just another 25% that crash and burn within a week and they die as a result of exactly the same pneumonia. Now, a fundamental difference between those is how quickly they can adapt to the lack of oxygen. And it's exactly the same sort of thing we see up here. 25% don't notice it, 50% find it difficult, 25% find it really hard. We have very strong evidence now to say they're exactly the same mechanisms. And if we can understand that, we can come up with different treatments and possibly even different drugs that will move everyone into that rapid adapting group and therefore increase survival. One of the striking things is how tolerant the Sherpa people are of the low levels of oxygen. You look at them, they don't look like incredibly physically fit athletes, but when you see their performance, their ability to carry high loads, their ability to work when we're suffering, even when we're acclimatized, it makes you ask the question, why are they so different? Now, there's been numerous experiments in the past done on the Sherpas, and classical physiology tells us that they are no different. But now we have questions that couldn't be asked before. It's something going on at a cellular level, right down in the tissues, in the muscles, and within there it's the fuel cells. They're called the mitochondria, where the oxygen is used. And that's what we're exploring in great detail this time.
The three important things that we're looking at are the microcirculation, the mitochondria and nitric oxide, which may control those two, are very relevant to the kind of things that we see in our intensive care patients. And it may be that we need to shift the way in which we treat intensive care patients based on what we find here.
One of the big parts of Xtreme Everest 2 is looking at nitrates, which are little chemicals that are released into your bloodstream and help to change how big or how small your blood vessels are. So we think if your cells are low on oxygen, then your body might be releasing more of these nitrate chemicals in order to deliver more oxygen. It's a bit like if you've got a traffic jam on a road, then you get the builders in to build more lanes so that more people can travel at the same time. So nitrates are a bit like the builders, perhaps.
We believe that we're right on the cusp of making a fundamental discovery that will have a major impact on our patients back at home.
The science of it is just so interesting, and to be able to come here and not just do science but see this is amazing.
The amount of data that we will be able to take home from this and analyse and hopefully change the way that people think about low levels of oxygen in critically ill patients. If we can change that, then it will definitely have been worth coming up here time and time again.